Hi, my name is Blaise Bourdin. I'm an associate professor of mathematics at LSU, and I also work with the Coast to Cosmos focus area at CCT. My main area of research is material science, and in particular fracture mechanics and numerical simulation of fracture mechanics. So that recent grant deals with enhanced geothermal system, and it's in particular the prediction of the outcome of simulation pattern for a geothermal system. And so the main idea is to produce electricity by harvesting heat that is stored in hot, dry rocks underground. And the way to do so is to inject cold water in fracture system and then pump it out and just generate electricity using a Carnot cycle, just using the difference in temperature. And what we're trying to do more specifically is to find a way to create these fracture systems. This hot dry rock system can be found pretty much anywhere in the United States, but the crack system don't necessarily exist. So we're trying to focus on two mechanisms. The first one that is thermal cracking, where you inject very cold water in hot rocks and create these tensile stresses due to the heat exchange. And the second system is called fracking, where you inject water and then detonate a charge inside the well, so that stress waves are sent and create these highly connected fracture systems. The potential of enhanced geothermal system is huge. So it's completely renewable because we just harvest heat that is brought in by a convective motion of the magma. It's completely carbon neutral, and it does not compete with agriculture for land use, which is something that is very often forgotten. So everything takes place underground, and the amount of available resources is huge. The estimate, there is a 2006 panel that was commissioned by DOE that estimated that the total amount of energy in hot dry rock system is 14 million exajoule. And to give that in perspective, if we were able to harvest 2% of that and convert it into electricity using current technology, that would give us 2,000 times the 2005 US annual electricity consumption. So that's really huge. And the estimate is by 2050, we should be able to provide 10% of the US electricity using enhanced thermal system without any technological breakthrough. The award from the National Science Foundation is $315,000, give or take something. And the specific work is going to be large-scale computing for the simulation of this crack creation pattern using a method that I've been working on for the last 10 years. It's called a variational approach to fracture. And it's very well suited to this problem because it allows to deal with a very large number of cracks propagating and interacting with each other in a fairly simple way. It's extremely computationally intensive, which is why it fits very well within the CCT mission. We created a geothermal work group with colleagues in geology, petroleum engineering, mechanical engineering, and computer science. And so right now we're focusing on code development and scalability. Most of the modeling has been done by myself and colleagues over the last few years. And so the award is for 3 years. So what our goal is within 3 years to have a functioning system and be able to deal with these very large systems.